Well, it's Monday, December 7th, and boy, is it cold outside today. With the wind chill, it's in the single digits and below zero in a couple of places. And then the weird thing is we got a ton of rain moving in tomorrow. Big storm coming with a lot of rain and wind. They're not talking about snow in our area, which is good. So they must be expecting it to warm up quite a bit overnight before the rain starts. At least that's the hope. Not thrilled about it being really rainy and windy, but I'd rather have that than have the snow right now. Even though it's December and it's New England, so, if we get snow, it's to be expected. Anyways, last time I was talking about the mill and was down here working on the mill, I mentioned that the next time we'd be getting together, I'd be talking about power in this thing, getting some three-phase power. Well, I thought about inquiring with my power company and asking them whether or not they'd see fit to come on down here and wire me up with some three-phase. But since it's not out there on the street, I don't think that's going to work out too well. For those of you who aren't familiar with three-phase power is a type of power that's supplied to many commercial and industrial districts because it's typically used in factories and in areas where you need to power large, mainly electric motors. A lot of the higher horsepower electric motors are three-phase, right down, from stuff that's used in big manufacturing to even large air conditioning units and compressors in big buildings. So. You go into cities, you're going to find three-phase power. You go into industrial areas, you're going to find three-phase power. But if you're in a rural area, very unlikely that you have three-phase power available to you. So what I've got here is I've got the typical residential power coming into the house. We've got 220 volt, and that's split into two lines, L1 and L2, and then there's a neutral. And you can use L1 to a neutral or L2 to a neutral to power a 120 volt circuit. Or if you go across L1 and L2, you get your 220 to 240. Different parts of the country, or depending on what era you were born in, you might hear that referred to as 204 to, there's a range in there. And it's going to be different depending on where you live. What you actually get, you put the meter on there and you measure it, might be different than what your buddy down the street's getting or the guy across town is getting. So anyways, I'm kind of getting off the subject here. The point is that what I've got regular standard electricity coming into the house here. I don't have three-phase. Three-phase, you have a third leg, what we call L3. So instead of just having L1 and 2, you've got that third leg. And it's an efficient way to run higher horsepower motors that are designed to be three-phase. So if you've got three-phase, you can always run a two-phase motor by just using two of the legs. But if you have two-phase, or regular power, and you want to run a three-phase motor, that poses a problem. And there are several ways to get around that. Most of them involve converting, or I think all of them involve converting the L1 and L2 into L1, L2, and L3. And there's a couple of ways you can do that, and there may be more. I'm going to talk about just the basic ways that most people know about. You have what you call a static converter. And a static converter basically is a box that's going to have capacitors in it. And what a capacitor will do is, I don't want to get too technical here, but there's something called a phase shift between the sinusoidal waveform that is present in AC, or alternating current. And if you were to look at all three legs of three-phase power on a device called an oscilloscope, and you were able to put each phase on a separate channel.
You would need a 4-channel scope. You only need 3 channels, but I don't think they make a 3-channel scope.
Anyways, you would actually be able to see a difference in the timing of the three phases. Okay, so there is a phase shift between the three phases. So what a static converter does, the type that uses capacitors, basically it uses a device called a capacitor to change the phase relationship of one of the two phases that you do have with 220 volt and create artificially the third phase that you need to have three-phase power. Okay, so that's one alternative. The other way you can do it is what's called a variable frequency drive, VFD. Now this is newer technology, and as with most technology, originally it was found in the industry, and it started to become more widespread in the industry, and eventually when that caught on, economies of scale kicked in, and now you're able to buy a variable frequency drive, which I'm going to refer to as VFD for short from this point on. You're able to purchase a VFD relatively cheaply. And when I say relative, I mean, you know, $200, $300, $400, $500, depending on, here's the kicker, horsepower. How much horsepower you need to supply is going to be the kicker. And you also want to look at the current rating, because most of these budget VFDs are coming from good old overseas Asia. And sometimes you gotta be a little wary about some of the specifications. But if they're giving you the max current and operating voltage, then you're in pretty good shape there. Now there are VFDs that operate on 120 volt input, plain old regular electrical lighting circuit, in and generating 220 volt three-phase out. Those tend to be for lower horsepower, smaller horsepowers. If we were going to put a VFD on this machine, we would want a VFD that takes 220 volt two-phase and converts it to 220 volt three-phase output. Now there are some advantages to a VFD. The number one advantage with most VFDs, and when I say VFD, variable frequency, okay, what a VFD is able to do is it's able to take the standardized 60 cycles per second, or 60 hertz, that's coming into the house. The AC alternating current is alternating at a frequency of 60 times per second. It's able to take that and change it to quite a wide range of frequencies. So it's able to control the frequency. So not only is it artificially creating that third phase that we're missing, it's also allowing you to manipulate those three phases and give you different frequencies. And what happens with a three-phase motor, when you're running it and you change the input frequency, you can actually change the speed of the motor. So now you've got a speed control built in. And you know, this has the variable drive on it up here with the belt, kind of like a snowmobile, kind of like basically it's like a constant velocity transmission, CVT, I forget what that stands for, but you know what I'm talking about. Your ATVs, a lot of your ATVs and a lot of your snowmobiles use this technology with the sheaves that actually move in and out and change the size of change their diameters to mimic step pulleys that are infinitely variable. Well, I shouldn't say infinitely variable, we don't. But anyways, again, getting off the subject. So you're able to change the speed. So what I could effectively do with a VFD on this is I could hook the VFD up, I could set this to one setting and leave it, and then do all of my controlling. And many of the VFDs will have a digital readout, and they won't tell you the RPM, but they'll tell you the frequency. And so what you can end up doing is you can make yourself a chart, and you can figure out what frequency you dial up is going to correspond to what speed you're going to get out on your spindles. So Mr. Pete there, Tubal Cane, he put one on a drill press, And he was quite honest about the results. I think in the end, if I'm not mistaken, on that particular, I think it was a Walker Turner drill press. I think he had mentioned that all in all, in the end, he probably would have not done it on that particular machine. There are certain instances where it probably will work better than others. You know, I thought about, am I going to do that down the road with the SIP drill press when I finish that? Don't know yet. I'm going to, you know, hold off on that decision for now. Part of the reason is the cost. Again, a cheap VFD for the horsepowers that I'm looking at, you know, probably going to be somewhere around $200-300 for a brand new one. And then, you know, you could buy maybe a used Asian import when those pop up on eBay and things like that. And the thing is, though, if you're buying a used Asian import, now you know you got no warranty. And hopefully if you're buying one of those cheap imports new, you're buying it from a reputable seller, so you know you're going to have some sort of back channel in case you have a problem with it, you know, if it fails on the warranty. Because the average person's not going to open up a VFD and service it. Quite frankly, there's a lot of integrated circuitry and stuff going on in there, and it's just, you know, not the kind of thing you work on typically, unless you're an electronics technician. And even then, you're going to maybe not be versed in the art of repair of VFDs. Okay, so what are we going to do here? Well, we have another option. We have what's called the rotary phase converter. The rotary phase converter uses what's called a slave motor to artificially create the third leg or the third phase. So what you actually need to build a rotary phase converter, there actually aren't a lot of parts. Of course, you want certain things like enclosures and things like that to keep it all safe. Okay, I mean, this is a good spot for me to put a disclaimer in here. Anything you see me do here, probably not safe. Don't do it. I shouldn't say that, but I mean, I like to try and be safe, and I try and follow all the precautions. But what I'm saying is, just because you see me do it doesn't mean it's safe. So take that for what it's worth. All right, so rotary phase converter. Not a lot of parts involved in building one, but you do need a three-phase motor. So you got to have a spare three-phase motor kicking around, or you're going to be able to pick one up somewhere. Lots of times you can go to scrap yards and find three-phase motors pretty cheap. And that's one source that you might be able to come across a three-phase motor. Or if you go to motor repair shops, sometimes they'll have a three-phase motor or a used one that, you know, they'll sell you cheap, that kind of thing. A lot of people don't want three-phase motors because they don't have three-phase power. So they take three-phase motors off of things they buy and they put on a 220-volt single-phase motor, and now they get a three-phase motor kicking around. The three-phase motor that's going to be your slave motor is supposed to be a minimum equal or larger horsepower than the motor you intend to drive with the converter. So, I've got my specification plate up here on the motor, and I know I already looked at it. This is a 2 horsepower motor I've got up here. It also tells me the maximum amperage rating, maximum draw of amperage, and the working voltage range on here. And there's actually a range in there. What we've got here is we've got a DOERR brand of motor, Doer Electric Company, out of, I can't quite make out the town, Somethingburg, Wisconsin, looks like. Alright, so what it says here is, it says that, you can see there's a lot of information there, but what we're mainly interested in is up in the upper left hand corner there. There's HP for horsepower 2. And then the other thing we're really interested in is the volts. And the volts say 208 to 230. So what they're telling you is there's a range of voltage that this will operate on. And then below it, it says amps, 6.6 to 6. Well, does that say 6.6 to 6.6? I think it does. That's interesting. Okay. Anyways, The reason why it says that is because typically those 2 amperage ratings will not be the same. That's kind of weird that that's the same. Usually what happens is the 2 amperage ratings indicate that at 208 volts it'll operate at a higher current. What happens is as the voltage drops, it has to draw more current to create the same amount of power or horsepower. So typically that 208, that lower number below it for amps will be the higher. In other words, it should be a higher number dash 6.6. So at 230 volts it draws 6.6 amps. And at 208 volts it should draw more than 6.6 amps. So I'm kind of surprised that says that. And then it actually also talks about there to the right that this motor can be rewired for 460 volt. And you only find that in factory settings for the most part. And at 460 volt, it only draws a measly 3.3 amps. So that's really all we need to know to figure out what we need to power this thing. Alright, so now we've got our specs. And the reason why I'm going with a rotary phase converter is because years ago, I had a large radial arm saw that I had bought at an auction. And it was a window manufacturing company that was going out of business. And there was this nice big old cast iron DeWalt radial arm saw. And at the time I was in the process of building my house, and I thought, wow, that would really be handy to have. And so I bid on it, and I got it for what I thought was an extremely reasonable price. Then I took a closer look at it, which I should have done before I bid, realized, son of a gun, the thing is 3-phase. No wonder why nobody was really that interested in it. You know, radial arm saws aren't as hot a property as they used to be anyways, but especially a 3-phase one. So I couldn't change the motor out on that thing because, you know, if you've ever seen one of those radial arm saws, the motor like fits very specifically on the head unit there, and it's direct drive. The actual arbor that the saw blade goes onto is actually the shaft of the motor. So the only way I was going to use that saw is to make a 3-phase converter. So, you know, went online, looked at several different designs, came across one that I kind of liked, and put together a 3-phase converter. I also years ago had bought several motors at an auction, and several of those motors were 3-phase. And up until that point, I had absolutely no use for them and hadn't gotten around to throwing them out. They weren't giving like any money for scrap back then. Now you can get a whole 15 to 25 cents a pound around here for a copper motor for scrap. So anyways, I ended up building a 3-phase converter and operating that saw off a 3-phase converter, and it worked flawlessly for the most part. And I'll talk about one issue with that converter when I get over here. So without further ado, I'm going to go grab that phase converter. We'll see what kind of specs it has. Okay, so here's my rotary phase converter. This thing's covered with a ton of dust because it's basically been sitting in the corner of the basement there on a chair for quite a few years. And you know, there's a few no-nos here. I basically was running this thing. Literally, I was running this Romex to a double pole breaker and sticking the double pole breaker in the panel temporarily while building the house. So that's why this has got just Romex leading to nowhere on it. It really shouldn't. Got a double pole switch inside this box here, which is important that you use a double pole switch in this design so that when you have this switch off, neither of the two legs are possibly still going through and able to backfeed and give you an electric shock that you'll, if you're lucky, you'll live to regret it. I've got a outlet here. This is my 3-phase powers coming out of here. This is a NEMA, I forgot what, but basically it's got 4 conductors. So I got a 4-prong plug that plugs into there. So I got my L1, 2, 3, and ground. And that's the output. So I bought this metal enclosure, put all of my components inside here. Which I'll give you a peek inside here and show you what's in here. But this is basically very simple circuit. And then on the back, we've got the slave motor. I've got the slave motor actually mounted to the box, and so this is my connections from inside here to the slave motor. And again, this shouldn't be Romex, and you know. So the slave motor is a Alice Chalmers electric motor, which I didn't even know that they made motors until I came across this motor. And this is an Alice Chalmers induction motor. So now what we're going to do, that data plate is upside down. Let's see how good I am at reading things upside down. And this is a 1.5 horsepower three-phase motor. So here's my problem. I've already said that the slave motor should be at least equal to, if not greater in horsepower than the motor you intend to drive with it. So my dilemma is, this rotary phase converter is too small to run my mill. What I'm not sure of is I'm not sure of whether or not it will run the mill but just not provide enough power when the mill's under load cutting. In other words, what I've got to find out is I've got to find out whether or not, A, will it run the mill but just not provide enough power? B, if it's not providing enough power, do I run the risk of damaging my motor in the mill? Okay, so what I'm going to do is I'm going to have to do a little bit of research, and there are a bazillion forums out there dedicated to phase conversion, rotary phase conversion. And it's funny because you go on woodworking sites and there'll be a section on phase converters. You go on hobby machinist sites, professional. You go on all of these different sites, and there's sections on phase converting. Even some of the tractor sites that I go to, and some of those forums, there are sections on phase converting, because chances are, if you're working on tractors, you might own some equipment that you tend to use from time to time, and you need phase conversion. So the next time you see me, I will hopefully have more information about whether or not I should even be attempting to use this rotary phase converter to run this mill.